Okay, let's talk about the composite pattern. So oftentimes we'll create these whole part tree structures. For example, in a paint program we might have lines and rectangles and text and other things. And we call these simple elements primitives. The user can group primitives together to form larger things called composites. These composites can be grouped into still larger composites and so on. And so we might in a paint program draw a line and a triangle, and then of course we can usually in paint programs highlight an area and drag it somewhere else. Right, so we still have our line and our rectangle, but then we could add other primitives. And then we can highlight even larger groups of composites, and we can move those around as well. We could treat composites and primitives differently. However, it often makes sense to treat them the same. So if I have an object C, C could either be a composite or a primitive. Right? And we might ask this object to draw itself. And we don't really care, is it a primitive, a single primitive, or is it a larger composite? We just know we want this thing to draw itself. Having to distinguish between object types makes the application a little more complex. The composite pattern describes how to use recursive composition, so clients don't need to make this distinction. So the intent of the composite pattern is to compose objects into tree structures to represent part-whole hierarchies. The composite lets clients treat individual objects and compositions uniformly. Okay, so the goal is to create kind of a data structure where we might have a line object, and we might have a triangle. Okay, but we might want to compose these into a larger group, which I'm going to call a picture. Right, and if we add, say, a circle, we might want to group those together into a larger picture. Okay, and the idea is, we want to be able to call draw on a line or a composition, in this case a picture, and we want everything to, it doesn't really matter whether it's a primitive or a composite. The composite, when we ask the composite to draw itself, it should just go through its children and ask each one of them to draw itself. Right, so we could do something like this. Create maybe line 1, line 2, maybe a triangle, call it T, okay, and then we would create maybe a picture called P. And we'd want to be able to do something like, say, P dot add maybe line 1, P dot add T, the triangle, and then at any point we should be able to say line 1 dot draw and expect the line to be drawn, or P dot draw, and what we'd expect there is for the line and the triangle that make up that picture to be drawn. Okay, so the composites draw is going to call draw on all of the composed objects. Okay, so let's look at the structure for this pattern. So we start with this interface, this component interface that has some operation. In our case it's draw, but again this is the generic solution. And then we have this ability to add and remove components, and we have this optional getChild method which will return one of the children of a composite. Okay, then we have a leaf class. So a leaf class has no children. These are the primitives. And then the composite is the interesting one. The composite has a collection of components called the children. And when you call the operation on the composite, it will march through all the children and ask each one to perform the operation. And what's interesting is because this holds a list of components, some of those children might themselves be composites. That's where we get the kind of the recursive nature of this. We could have a composite inside a composite inside a composite. Okay, and then of course the client doesn't know about any of this. It just says to the component, go do the operation. Okay, so let me draw a class diagram for our little example here. So we have a client, and we have this class, this interface called graphic. And we're going to have our operation is called draw. And we'll be able to add a graphic and remove a graphic. I'm going to leave off the optional getChild. Okay, then we have our primitives, our leaf classes. We have a line, we have triangle, okay, we might have a circle, we might have many different primitives. Okay, but then we have this class called picture. And the picture is going to have a collection of graphics that we will call children. Okay, and what we're going to see in a second is when you call draw on a picture, it's just going to march through children and call draw on all of the graphics. Okay, so let's look at some code. Okay, so here's our graphic class. I'm sorry, not a class, it's an interface. We just have the draw, that's our operation, and this ability to add and remove. Next, let's look at the picture. Picture implements graphic. Okay, so that means it's going to provide a draw, an add, and a remove method. This class has an array list of graphics called children. And in the constructor, we will create the array list. Of course, the children array list can hold primitive things like lines and circles or rectangles, or it can hold other pictures, because a picture is a graphic. Okay, and then when we draw a picture, we just go through all the graphics in the children collection, and we ask each child to draw itself. Again, the child might be a primitive, or it might be other pictures, resulting in recursive calls to draw. Okay, and then to add, we have this one rule that you can't, a picture shouldn't be able to add itself as a child. So this check here is just to see, is the thing we're trying to add, we want to make sure it's not, the picture that the picture that's holding all of the children shouldn't hold itself. Okay, so as long as g is not equal to this, we can add, otherwise we can throw some exception. And then to remove, we just call the ArrayList remove method. Okay, so let's look at some primitives. We have a circle. Circle also implements graphic, and it has a draw method, which I just simulate drawing a circle here. It also has these methods that, remember, come from the graphic interface, add and remove. And these are not really appropriate for the primitive types, right? The circle and the line. But if we want to have this composite pattern, this is kind of a trade-off we have to make. I think this is kind of unfortunate, but these methods must be overridden in the primitive classes, and they should really just throw exceptions because we shouldn't be able to add to a primitive. Okay, our line is similar. It implements graphic. It does draw itself, and then we have exceptions on add and remove. And lastly, the driver here. We create a couple lines, a circle. Okay, then I have this print graphic method, which takes a graphic. We don't know if it's a primitive or a picture. Okay, but basically we just do this print, and then we say g.draw, and those calls were all to primitives. L1, L2, and C1 are primitives. But now we create a picture, and we add L1, L2 to the picture, and we call print graphic. So now the graphic is a picture, and when we call draw on the picture, we're going to go through the two children, which will be those two primitives, and we're going to each one of their draw method is going to be called. Okay, and then lastly we create a circle, a new picture, and we're going to add the picture P1 to the picture P2. Then we're going to add the circle, and we're going to call print graphic. And again, this time we're passing in P2, and this is basically very similar to what we had here. Right. So we're going to call draw on this guy right here, and then he's going to go through his children. Right. So first here it's going to call draw on this one. Since this one is also a picture, it's going to march through its children, call draw on this line, call draw on this triangle, okay, and then come back and move to the next child, which is the circle, and we will have moved through the entire list of this guy's children and called draw on them. Okay, so that's the heart of the composite pattern. Let's just review the participants here. We have the component, declares an interface for objects in the composition. We have a leaf. A leaf has no children and defines behavior for the primitive objects in the composition. And we have the composite, which stores child components, which may be leaves or other composites, and requests that each child perform some kind of operation. And some consequences of using composite defines this potentially recursive hierarchy, which is often desirable. Whenever a client expects a primitive object, it can also take a composite, so that's nice. It makes the client code nice and simple. So the client doesn't really have to know about the difference between composites and primitives. It's easy to add new kinds of components. And one drawback I've already mentioned is it inherits the leaves inherit methods that are not really appropriate for the primitives, and that's just something we kind of have to deal with. Okay, so that's the composite pattern.